Hello everyone, welcome to our notes today on 13.4. We are on a very important topic. Mean and standard deviation is very heavily rooted with statistics. So make sure you pay very close attention to this lesson. This is extremely important for this lesson and for future lesson and chapters. So make sure you do a good job, pay close attention to this video lesson. The definition of the mean is it's another way of saying it's the average. It's another measure of center. There are three measures of center: the mean and the median and the mode. And today we're talking about the mean. So the way you find the average, or the way you find the mean, is you add up all the values that there are and you divide by the number of data entries that there are. So this sigma right here means the sum. So it's the sum of all of the data entries and then dividing by the number of data entries that there are. That's how we find the mean. And mean is sometimes referred to as x bar. So if you see that x with a dash on top of it, that's read as x bar, and that always means the mean. Okay, x bar is the same thing as saying the mean. So we have an example problem here. Use the following 15 data entries to find the mean, or to find x bar. So why don't you guys pause the video, add all of these up, 48 plus 51 plus 46, add all those up, and then divide by the number that there are. Please do that right now. So when you did that on your own, here's what you got. You added all of them up and you got 493, and there are 15 data entries, so you divided by 15. So here is our mean. X bar equals 59.533. I'm sure you've done that before in previous math classes, but that is how you find the mean. You add up all the data entries and divide by the number that there are. So now that you know what the mean is, we now have to talk about standard deviation. Standard deviation is probably something that you haven't had before. What standard deviation is it shows the variability or spread of the data. So if your data entries are all very clustered together, you're going to have a small standard deviation. If your data entries are very widespread, now your standard deviation is going to be a lot higher. So the smaller the standard deviation, the more clustered the data is. Okay? Because what standard deviation does is it measures the average distance away from the mean. So if your standard deviation is very small, that average distance is very small. That makes clustered data. If your average distance is very spread out, that's very spread out data, that's going to make a higher standard deviation. Our calculator shows up like this, and we're going to do this here in just a little bit. But x bar, this is your mean. So we'll find this in our calculator. And then this SX right here, that is the sample standard deviation, and that's what we always use in this class. We'll use sample standard deviation SX. Be careful, you also see this sigma x right here. We'll use this from time to time. You'll use it more in upper level statistics classes. In our classes, we use SX for standard deviation. Okay, so here's an example of why we calculate standard deviation. Mathematicians, they need to have a clear-cut way of saying what is close to average or what is far away from average, either above average or below average. So mathematicians, a way of communicating different numbers is by using standard deviations away from the mean. So here's an example. We have these 5 dogs. Which dogs are really tall? Which dogs are average? Which dogs are maybe kind of tall but not really tall? You know, we need to be able to communicate so that we can all be on the same page. So here's the heights of all the dogs. 600 millimeters, 470, so on and so forth. Okay? So the first thing that statisticians do is they find the mean. So we add up all those and divide by the number of dogs that there are, which is 5. So the 394 is the average, or the mean, and that's represented by this green line right here. That's the average height of dog. Okay? So now what statisticians do to find the standard deviation is they find the average distance away from the mean that each dog is. So this tallest dog right here, he is 206 millimeters above the mean. Okay? The second dog was 76. This dog was a small dog. It was 224 below the mean, so on and so forth. So you subtract each dog's height from the mean. And then what the the next step in finding standard deviation is you square each and every one of those distances. So this distance was 206, this distance was 76. We're going to square all those distances. 206 squared, 76 squared, so on and so forth. And then we're going to add up all of those squared distances. Once you add that up, you get 108,520. To find standard deviation, the next step is to divide by n minus 1. So there are 5 dogs, so we're going to divide by 5 minus 1, which is 4. This term now, class, is called the variance. We don't do this too much in this class as far as using the variance. You'll again use this in later on statistics classes. So the variance is 27,130. Final step in finding standard deviation is to square root the variance. So you square root 27,130. Once you do that, you get 164.71. This class is one standard deviation away from the mean. So the standard deviation is 164.71. And so if we add a standard deviation to the mean, so again everybody, here is the mean. This is x bar. This is one standard deviation above the mean. So this is sx plus 1. That's one standard deviation above the mean. And this is xx minus 1. That's one standard deviation below the mean. So now we have a way of communicating. We could say, well, all 3 of these dogs, this one, and this one, and this one, are pretty average height of dogs. They're all within one standard deviation from the mean. We can now say that this Rottweiler is a tall dog because it's more than one standard deviation away from the mean. It's not like any gray area anymore. It's like, well, it's pretty tall, it's really tall, it's very tall. There's not as much gray area. We say that dog is higher than one standard deviation above the mean. That's a tall dog. And now this dash sound right here, statisticians have a way of saying that dog is one standard deviation below the mean. That's a short dog. Okay, so that's why we use standard deviations. It's a way of communicating different statistical values. So now that we have that example problem, let's find one on our own. Here's what we're going to do. Once we find the mean, we subtract each data entry from the mean. So that's the first step. Subtract each number minus the mean. And then you got to square each of those differences. After you square each one, then you're going to add all of them up. Find the sum of all those numbers. And then the fourth step, once you have the sum, you're going to divide by the number of observations minus 1. Okay, so divide by n minus 1. And that'll get you the variance. And then the last step is to take the square root of that number. Whew! It's a lot of work. It's kind of monotonous work. You do the same thing over and over again, but there is a value in knowing it. So everybody, we're going to find the standard deviations from problem number 1. Okay, so these are all the values on the left side. 48, 51, 46, all of these numbers right here. You already found the mean of all these numbers, and the mean was this 59.53. Okay, so now for each and every one of these 15 values, it's a lot of work, but what you're going to do, it's not difficult work. You're just going to subtract the mean. So for all of these numbers right here, you are going to subtract the mean. Okay, so it's 48 minus 59.53, 51 minus 59.53, 46 minus 59.53, so on and so forth. Once you get that difference, 48 minus 59.53 in the first cell there, then you're going to square each difference. So what I did here now is I took 48 minus 59.53, and that number is 11.53, a negative 11.53. And then you're going to square each of those differences. Okay, so that's what I did next. I squared each one, and if you square this negative 11.53, you get 139.94. I rounded to 2 decimal points. I want you guys to do the same. So class, right now I just want you to fill out this chart so you could have it in your notes. Take each observation, subtract the mean, get that number, and then square it. Now do that for 51. Subtract the mean, get that number, and square it. Then do the same thing for 46. Subtract the mean, get that value, and then square it. So you guys could pause the video, and I want you guys to write down everything that I have wrote down on this slide. So pause the video, write all those down. Pause the video, write all those down. Once you have done that, the next step is to find the sum of all of these red numbers right here. It's the sum of all of the x minus x bars squared. So we got to add up all of these red numbers. And once you do that, I encourage you guys to do that on your own. It's good practice for you. I'll tell you what that sum is. That sum is 1,143.72. So now the fourth step is to divide by n minus 1. There are 15 data entries. So we're going to take 1143.72 and divide by 14. 15 minus 1, obviously 14. Once we do that, we get our variance, and our variance is 81.69. Last step is to take the square root of the variance. So our answer here is the square root of 81.69. Again, round to 2 decimal points, please. It would be 9.04. Our standard deviation is 9.04 for this. Now we can say if the mean is 59.53, I can add 9.04, and that's one standard deviation higher than the mean. I could subtract 9.04 from the mean, and that's one standard deviation below the mean. And we're going to use those terms a lot here in the next few chapters. Whew, that's a lot of work. You have to do all that by hand. And you do have to do that on a worksheet. You will have to do that on a chapter test. Even though our calculator does it all for us. So everybody, let's do it the easy way now, please. Let's take out our graphing calculator, and we'll do this on our own in our graphing calculator. So here's what you're going to do. When you take out your graphing calculator, you're going to press Stat, as we've done many times in this chapter. And then we're going to edit our list. I've already entered in these numbers into list 3. I've put in 48, 51, 46. You guys do the same thing. You can do it in list 1, list 2, list 3. It doesn't really matter. As a reminder, again, if you have to put 48, you press 48, enter, and then you're going to press 51, enter. If you ever want to clear a list, you just highlight it, press clear, and then down, and the list is gone. So put all those numbers, please, into one of the lists. Be very careful that you enter in the data correctly. Your standard deviation will be off if you enter in a single number incorrectly. So be very careful. Okay, once you've entered the data in, now you're going to press Stat, and you're going to go over 1 to calculate again. And again, it's going to be number 1, variable stats. So you're going to press Enter. It asks for what list we want the standard deviation for. I entered my data into list 3, so I'm going to press second 3 to get list 3. You guys press whatever list you use to put your data in. So I'm going to calculate, and my SX is my standard deviation. You can see my X bar right here, 59.53, so we did that part right. SX is 9.04. 9.038 rounds up to 9.04. So as you can see, we got the exact same number using our calculator. On your test, if you want to use your calculator to check if your standard deviation is right, I highly suggest that to you, but it is an important skill to know how to calculate standard deviation by hand. So you have to do all of this work to get 9.04, just to make sure that you know that you have to do all that, but you can check that using your graphing calculator. I hope all that made sense. Tomorrow, obviously, let me know if you have any questions about finding that standard deviation. It's a very important topic, so I want to make sure that you have a good understanding about how to calculate it.